just to recap then, so we've got finding the coordinates of the point of intersection of the two lines, but just remembering that the lines are not lines, they are what? All the possible points, so an infinite number of points. So that's actually quite a good, mental picture to have, is they aren't lines, they're lots of points where you can't actually see the difference. And that really does change your approach to solving some of these things. And where two lines cross is actually where one of those points applies to both the functions. Okay? So the x is, obviously we can always share the same x, but when we've got two different functions, if the lines are separate, for the same x going in, you would have a different answer. Y would be different. But if they cross, we put the same x in, we get the same y out. So two different functions still have the same answer, is the principle. So I use this notation, which you will get to see more and more. Function notation just means the function that is applied to x. So in this case, it's times m plus c or times a plus b. That's all it means. So nothing too fancy. And we won't actually use it much more at the moment. I just wanted to introduce that to you. So let's have a look then at what we need to do. So I'm going to have a look, if you, in your book, you can follow through. So we're going to have a look at example 13 on page 159. Right? So it helps you go back and follow it. So it says, find the simultaneous solution to the equations y equals 2x minus 1 and y equals x plus 3. Now, there are several different ways to do this. Just like there were several different ways to look at the gradient of a line, the equation of the straight line. So what we'll do is we'll go through all, I think, including the graph method, using your calculator, or even just graphing it yourself. There are 4 different approaches. And basically, all 4 methods will work whichever one I give you to do. But some of them will be like, oh, why did I bother doing all of that? I could have just done this one. Okay? But you've got to make that decision. Right? Do you remember back to the quadratics when we had the formula for solving quadratics?
Yeah.
Who can remember that?
Plus or minus. Negative b minus square root b squared minus 4ac all over 2a.
Cool, well done. The song obviously helps. Just to say, the quadratic formula always works. However, sometimes it's just not necessary because there's an easier way of doing it. And it's the same thing with simultaneous equations. So what they're doing the first way is we are basically just making a statement about, well, if two lines are the same, they meet at a point, the x and the y values therefore are the same, we can make 2 statements from these 2 equations. So my first equation, my second equation, we know that at one particular point, we know this. So I'm going to say, I'm just going to call it y1 and y2. Right? You won't see that in the book, it's just to try and help you, and we don't need to keep it there. And we've got x1 and x2. Right? So what we can make the statement is, actually, y1 is equal to y2, because they're the same value, yeah? That makes sense? Equally, though, we can make another statement. What can we say? No, actually, well, yes, it does, but even more than that.
2x1 minus 1 is equal to x2 plus 3.
Is equal to x2. Okay?
Because if those two are the same, that means that the values of those have to be different. If y is the same, and that means that they have to be
yeah. Logical statement. Okay. Now, just to say that there is no need really to say y1 and y2 because what They're not different, they are actually the same number. And in the same way, we don't really need an x1 and an x2 because x is the same number. So what we're actually going to do is just solve 2x minus 1 is equal to x plus 3, which we've done before. So we've got our methods for doing that, haven't we? Yeah, well, we've got no like terms on one side at the moment, so that idea though, careful with, not moving. Yeah, we're going to try and now eliminate things to leave us with what? X equals something, okay? So you can do anything you like. Remember what I said, you can do anything you like as long as you abide by the rules and you abide by the order in which things have to happen. So actually, it doesn't really matter what you choose to do first. You will always end up at the same point. It just depends whether you go the long way or whether you go the short way. Alright? Obviously, we would all like to be as efficient and quick as possible, but you know what? What I want to get over is it doesn't matter. Sometimes if you just go, oh, I did that, oh, I didn't need to. Oh, well, I'll just keep going. It doesn't matter. So we're balancing this. This equal sign means that is equal to that. They have the same value. Therefore, as long as I do the same to both sides, I don't ruin that. And that's all that matters. Okay? So what do we do first? What would you like to do?
Add 1 to both sides.
Add 1. Now, do you remember I said I have a particular way of writing it, but you do it how you feel, right? I'm going to add 1, and I'm going to write it there, because that undoes the subtract 1, and therefore I need to add 1, and I'm going to write it next to the add 3, because that's where you add 1. You add it to the 3, you don't add it to the x. X doesn't change. Does that make sense? Okay. So that then becomes, well, 2x minus 1 add 1 stays as 2x. X add 3 add 1 is x add 4. Okay? Now, so next stage. Please.
Subtract x to both sides.
Yeah, so again, I'm going to write it here. I'm going to do, well, I'm subtracting x because that's what I've got there. So I'm going to subtract x from the only thing that's on that side. Now, we discussed this yesterday. You told us very well, Lucy, that what is it not?
It's not 2x.
What's 2x minus x not?
Oh, it's not 2.
It's not 2. Because you were telling me, like, 2x's means 2x's, 2 times x. Right, therefore, another way to write this, just in case it helps anyone, 2x's could also be x plus x, x plus 4. So if I subtract the x like that, it makes sense that then, oh, okay, I'm left with 1x, and I'm left with 4. Yeah. Yeah. Okay, so far, I've found the x coordinate, so that would be one solution. All right, but well, no, not sorry, one solution. That's one part of the solution. So I know that when you put x is when 4 goes in, I should get the same answer. But the question is, what is that answer? So does it now make perfect sense that, well, if 4 goes in to there or there, I don't know why I drew a line there. If 4 goes in to either of those two, I should get the same y answer, yeah? So it doesn't matter which one I use, if I'm correct with what I found for x. So there's a check. It's like, well, I would check and go, right, y equals 2 times 4 minus 1, which would give me y equals 7. And then I'd probably do this mentally and just do, well, y is x plus 3. Well, that's, so y is 4 plus 3, which makes 7. Right, I've got the same answer, therefore I'm happy that y is 7. Alright, now again what I would suggest is you do one of those on paper to give the answer, and then the other one you just do mentally, just a quick check. Takes a couple of seconds to do it, and quite often what people do is they find an x value that appears to work for both, but then it gives a different y value. Okay. Now again, you wouldn't be expected to go any further, that's your answer, but what does that mean for us, just to check our understanding? So 2x minus 1 and x plus 3. Would you be able to tell me how to sketch them, just to show what it means? So what does 2x minus 1 look like?
So go across the 2 and go down to minus 1, so like 5. It means it crosses on negative 1 and 9.
Alright, so it crosses at negative 1. Yeah? Does that make sense?
Yeah.
2x minus 1.
And go up radius.
So across 1, up
2.
2. So that would actually be at
1.
1, so I'd have a point. So I only need those two, so I'm just going to draw my line like that. What would x plus 3 look like? So it crosses at 3, so I'll do 3. And then when I go across 1, I go up.
2.
So it's y equals 2x minus 1 and y equals x plus 3. So that was across 2, so yeah. So cross 1 up 1, okay, which means it goes to 4. Right? Which would give me a line. Now I'm going to do it slightly different than drawn, just because I want to show that they will cross. How do we know they will cross at some point?
Because the gradients are different.
Different gradients. Now, this point, therefore, will be where? So I read down. 4, and the y coordinate will be 7. So that's what we've found. 7 and 4. Okay? That's what the whole thing means. Right? Do you see the links between everything now?
Yeah.
Which is good. Right? So, what we've got so far, we've got one method which is equating the two, and when we do that, the reason why it works for this one is because both of them are in the form y equals mx plus c. Alright? Now, they're not always, because you've seen before that the equation of a line could be in general form. And we've got different methods for that. But what we'll do, I'll give you a bit of time to practice that now. Okay? So, having a look at exercise 70.1 and over to the page, and you'll see question 2, it says solution by substitution. That's the next thing we'll do. But what I would get you to do now is from questions 1 and 2, why do you think there's a difference? Why did they stop at I and start a new question when it's the same thing? Why do you think that happens? Yeah, something changes. It's the same method, but something changes. And they want to give that to you. So, what do you think changes from question 1 to question 2? So there's negatives in there, yeah, negative gradients. What about, there's something else as well. There's not just x is in a different place as well. Okay? No, same method, but what they're trying to challenge you, I guess. Right, so have a go. Make sure, don't do them all. Do a range from question 1 and 2. Have a look and look at what changes and see whether you can find, well, I should be able to do that one and then they're the same, yeah, fine. Then, but that one's slightly different, I'll do that one. Do that. Challenge yourself. if you don't mind, can I go through 2a
Yes.
just to check? Alright, so 2a we've got y equals x plus 4 and y equals 5 minus x. So first step is to say x plus 4 equals 5 minus x, where we're looking for it. Now there is a common mistake here, which we're going to try and avoid. So what would we do? What would you like to do first? Okay, so if you add x to both sides, you then end up with 2x plus 4, and you're left with 5. Now what people tend to do is they look at x and they look at minus x and think, well, the x's disappear. Right? That's what some people do. I'm not saying you do or you are. Okay? Again, it's that whole moving thing.
Yeah.
Right? If you think moving, because they forget to change sign or whatever, but they move the minus x to the x and they think x minus x, no x, so it suddenly becomes 4 equals 5. That what? That doesn't make sense. Okay? So we just make sure we get that right. Now, as you notice, we dealt with the x bit first. Now we deal with the numbers. It's fine. You can do it either way round. So what do we do next? Subtract 4. So we're left with 2x equals 1. Divide by 2 both sides. Gives me x equal, and I would leave it as a half. I mean, obviously this is a nice easy one. It's 0.5. But 1 over 2 is perfectly reasonable. Okay, if you ended up with a fraction that could be simplified, you'd maybe expected to simplify it. But you know your calculator can simplify fractions quite a bit, so if necessary. Alright. Is there another one you would like to go through now, or did you want 2D?
Yeah, Rosie wanted 2D.
I'll do one more with you. Okay, so part D. So we've got y equals x minus 4 and y equals minus 2x. By the way, I didn't do the y. Don't forget to do the y in your exam. Would you like me to do the y in this previous one? Okay, before I move on. Because it's a fraction, sometimes people get confused. But which one am I going to use? This one or this one? You choose. Choose the easy one. Choose the first one because it's easy. So y equals a half plus 4. And the answer is 4.5.
I agree. Oh.
Yeah? Leave it like that. Yeah, exactly. That's why it's 9. If I'd done 5 minus a half, it's still quite easy. 5 minus a half is still 4.5.
What?
Okay.
4.5. 4 cakes, and they give you half a cake, or maybe you have 4.5 cakes.
4.5 cakes. That's why dealing with fractions is so much nicer, so much easier. Okay, let's have a look at D then. So again, we're told, by the way, remember we're in this situation, you are asked to find or solve the simultaneous equations. So find the simultaneous solution, right? It's not always the case. So only when we're trying to find the simultaneous solution, we then put x minus 4 equals minus 2x minus 4. So first thing you would like to do, I would always get rid of any negative x's. So I'm going to add 2 x's. Okay, that's what you do. I would just, you don't have to, but I would try and avoid any negative x's at the end. So I end up with 3x's minus 4 equals minus 4. And again, a common mistake would be to say minus 4 is nothing. Okay. Well, no, actually in this case it's fine because we do plus 4 plus 4. So you actually do end up with 3x equals 0. And again, people go, what? No, can't be. No. Yes, shall we divide by, no, it can't, it can't be 0, we're not allowed 0, but actually, what we're saying is 3 times something is 0, and therefore the only thing something could be is?
0.
0. It's a perfectly good answer. Now, that would suggest, if we again understand fully, that if x is 0 when they meet where on the graph?
On the y-intercept.
On the y-intercept. Now, is there any way, looking at the equations, that we can find the y-intercept quickly?
C, -4.
Negative 4. And you'll notice that they are both negative 4.
So we know that if that's like that, it was 0.
So we see, look, straight away, we probably, again, it's one of those things that you don't need to know, but it's there if you really fully understand. I would look at that and go, the y-intercept is the same. Therefore, they cross at the y-intercept. Therefore, my solution is 0 minus 4. Okay? Again, you don't have to be able to remember that, but if you do, imagine how much time that would save if you could remember that, right, if it came up. But equally, we've still found our 2 solutions anyway. Again, you'll notice what I'm doing. Obviously, you're not going to draw a little box, but highlight your answers, put an underline, your answers, draw a box. Make it clear, especially when you've got lots of working going. So with this one, for instance, you'll have working for the x, and then you might have a separate set of working for the y. Don't let things get lost. Make it very clear where your solutions are. Alright?
Break